with that, I'll pass it back to Junwei.
Okay, thanks, Shawn. Very nice presentation. So we can open up the floor if anyone want to orally ask questions. I can unmute you, or if you prefer to type in the questions, you can still do so right now. I'll start with a few questions that I have received. While you're doing so, I can just pass some of the questions to Shawn. One question is, great talk, Shawn. Do you think that per stage gas productivity might also be estimated from an integrated microseismic geomechanical approach when properly calibrated in a basin?
Yeah, certainly. And in order to do that, I think the next step is to take these models and feed it into a reservoir simulator. To do that, and we've done a few projects with clients doing this, so what we can do is take the prop and concentration and load that into the reservoir simulator as an estimate of the change in hydraulic conductivity of the primary fracture. But what we're finding is we also have to account for the so-called, SRV, the stimulated volume around it. So secondary to that, we're also looking at creating a grid with either the total extent of the discrete fractures that have been activated around the primaries as a second material. We can maybe use the amount of shear displacement based on those seismic moments to try to characterize how much self-cropping mechanism may have taken place based on the shearing, if there's laboratory studies to sort of quantify that, or at least use that as a enhanced permeability zone around the hydraulic fracture superhighway, if you like. And yeah, there's unfortunately not published, but we've been involved in a few cases like that of taking it to the next step, looking at the reservoir simulator, and then that's a point where I think either for an oil well or a dry gas well, you can look at using the information to optimize production.
Nice. Okay, so the second question I have is, so you talk about the wet events and dry events in one of your slides. What would be the typical way to distinguish these two types of events when we are looking at microseismic data? Do you have any general suggestions on this?
Yeah, I do. It's a very good question. And the slide I showed when I introduced that, maybe I'll just go back, and it's always easier to talk to a picture than just say it in words. But yeah, this was the slide where I introduced the wet and the dry microseismic. This was part of a paper that we gave at ERTEC a few years ago, and we used the model to look at different interpretational methods to distinguish wet and dry events. We found the easiest way to differentiate was just a distance time plot, or sometimes called an RT plot. The wet microseismic events showed a nice cloud that started at the fracture initiation points, diffused away slowly with time, or moved away slowly with time from the fracture initiation points. The dry events were, in some cases, again, early on, far from the initiation point, and we could differentiate those. And I think that's probably the simplest way we can differentiate between the two. But in the paper, we also looked at, was there any expected change in the moment tensor? There was maybe a slight indication of a change in the moment tensor, but for both wet and dry, we were predicting some opening modes on top of the shearing mode for both classes. But the other thing we found in the study was, out of the model, there was a change in B value that was naturally popping out between the wet and the dry. So the wet microseismic, we were finding a B value of 2, and dry microseismic, a B value of 1. And of course, that's of interest. It's I think there's a lot of interest around using B values to enhance microseismic interpretations. And there's been field observations where hydraulic fractures are maybe closer to a B value of 2, and fault activations being closer to a B value of 1. So it's interesting those differences in B values naturally popped out of the model. It's the same physics, same fracture network. It's only the mechanism difference of these sources in microseismic driving that B value.
Yeah, I guess the geomechanics modeling you're showing in this talk can also do something to help us understand more about the wet and the dry type of events.
It could, yeah. That's a good point, Julian. I should maybe I should have covered that as the first way to do it. But yeah, even without going to a full geomechanical approach, um, again, I think that RT plot or distance time plot, they're becoming more and more common delivery for microseismic imaging, and I think they're a great way to differentiate wet and dry.
Okay. I guess the last question I have here is, it's a follow-up on the geomechanical modeling. So currently there's quite a few geomechanical software available and different techniques available for people to use. Some of them based on continue, some of them discontinue, and some of them are like particle-based. So when people are choosing a geomechanical techniques to do geomechanical modeling, do you have general guidance for people to to pick what kind of techniques maybe should be selected for microseismic modeling?
Yeah, it's a very good question, and there's, I guess you could broaden it. The question sort of kind of points to this sort of scenario of we have classical planar fracture models that are been around for years and years in the industry and are commonly used to design hydraulic fracture systems, versus more advanced models that are becoming, there's more of these becoming available over the last few years. And, obviously, working for Itasca, we have a vetted interest in our internal codes, but we also internally have at least 4 different codes. I showed 3DEC here, a discrete element code, but we've also used FLAC 3D as to interpret, say, pressure hits, and we've also used particle flow code as a tool for this type of scenario, as well as a new model that we've created in conjunction with British Petroleum BP that we call Excite. It's a new tool we're quite excited about that's just being commercialized. But so that's a commercial answer. So moving on to a more technical answer to the very good question. I think it really comes down to the assumptions built into the model, and every model is going to have certain assumptions built in. We like to use 3DEC, for instance, as I've shown here, where we can account for discrete fracture networks. It's very good at predicting a specific microseismic catalog or forecast that could be then matched to field observations. And but each one of these models that can be used, I think each one has limitations and advantages. And one useful industry attempt to try to reconcile those differences, I think, is the work being done at ARMA. So if you're not aware, ARMA, through their hydraulic fracturing community, had what some people are calling a frac-off, meaning they described a number of benchmark examples and then invited a number of different institutions and corporations with different models to compare their models based on those prescribed input conditions. And we participated in that exercise with 2 of our models. I think it was very useful and provides a good comparison of what one model could do over another, and provides, I think, better guidance in terms of what each model is saying. But as with any modeling exercise, I think the simple answer to the question, and apologies, it's been kind of a long-winded answer, but it's a good question, and obviously sparks an interest from my side. But the simple answer would be the same way as picking any model, is simply to make sure that the assumptions built into the model are significantly covered and not impacting the ultimate interpretation.
Okay. All right. Yeah. I don't have any questions coming in. So with that, I guess we
Good.
can
Well,
webinar.
yeah, great. Thanks, Xunwei. And if people have more questions after the fact, I'd be happy to exchange emails. And I mentioned a couple papers here. Always happy to pass on reprints of papers for the different aspects that we've discussed. But thank you very much for taking the listen this morning. And thanks, Xunwei, for coordinating this.
Yeah, my pleasure. Thanks, Shawn. Thanks, everyone.